Okay. Last Wednesday, we have discussed the sequences. There is terms. It's called the monotonic and bounded sequence. So we can define the sequence as increasing or decreasing. Depends on how the sequence will be looks like in order. Okay. So for example, for increasing monotonic sequence, the the first term is less than the second term, and so on and so forth. And if you are looking at if sequence is decreasing, then the value is decreasing. Okay, yeah, that's I think understandable. So for example, if you have an let's say some just easy sequence. If an is 3 over n plus 5, then a n plus 1 will be 3. Or we can say that this is n plus 6. Okay, and since the 3 n plus 5 is bigger than n plus 6, okay, then this will be resulting the sequence is decreasing. Okay. So to know whether the functions or the sequence is increasing or decreasing, you can check its n value, okay? The n plus 1 value, whether it's lower or greater than the original terms. Okay. Okay, that's how to know whether the sequence is increasing or decreasing. Okay, you check the n plus 1. Okay. And then another definitions that important is uh, not every monotonic is bounded, or not every monotonic will be converged. Okay. For example, if you look at if this is the sequence, let's say this is n and this is the an. Okay. If you look at the graph, okay, uh, we never know when it will be bounded. If we look at the pattern, okay? It's all going up. Okay, it's different from what we did before. What we did before is something like this. Okay, this case, okay, you can imagine as if there is a line here, and the value of this line will be approached. Okay, will be approached by the value of the an. Okay, we can use the definition from the limit, right? Let's say this is L value. If this happens, then it's converged. Okay, so it's converged. But here it's diverged. Okay, so have you understand the difference? Okay, so the first one or the left one, like we did in the definition for limit, the functions is, we can see it's increasing, right? But it has some, we call this phenomenon is it's called bounded. Okay? It's called bounded. bounded to this line. Okay? Or in previous terms, we can prove that by tools limit. Okay. But if this happens, the right side, you see the value of an, it's always increasing. It's monotonic, but it doesn't have any bounded value, right? So it will be diverged. Okay. So that's the difference. Okay. So we can come up to some definitions. Okay. So we can come up to definition. So every bounded monotonic sequence is convergent. So we need to state two conditions. Okay, the function or the sequence is monotonic, and the sequence is also bounded. Okay. Based on these two terms, we can conclude that it will be convergent. Okay. Let me write in more details. Maybe here. Sequence an bounded above if so the line will be in the top one if there is a number, let's say the number m, such that so when the order increasing, an will be less than that m value. It's the same thing as what we draw before. Okay, this is just a statement. And similarly, the sequence bounded below. If there is a number let's say the small m, such that an greater than m or n greater than 1. But there is a case also if a sequence is bounded above and below, both. Okay. Oh wait. Before that, let me just say uh, the conclusion first. The conclusion from these definitions will be if a sequence is bounded above or below or both, all this is bounded sequence. And again, because I mentioned both above and below, then it's also not always converges. Okay. For example, if it's going up and down, up and down, up and down, and it's constantly keeping that in that way, then it's also diverges. Okay, because it has at least two values, two bounded values, right? So again, back to the first conclusion from all this and from the monotonic sequence, what we can conclude is the sequence should be monotonic and bounded, both of them. If only one, then we cannot conclude the sequence is converged. So both monotonic and bounded, then it will be converged. Okay. And this two statement is just representations from this picture, or maybe if I draw the other one, uh, let me make this not L but big M, and maybe another one here is the small m. Okay, another sequence like that. So meaning it's going below and it's bounded here, bounded below. Okay. If you want to draw the what's the statement means, okay, the big M and the small m. Okay. Okay. Any questions first? Okay. So the keyword is monotonic and bounded. Okay. Okay. Let me give you a simple example. I think the example also we have mentioned before. So I think we can go to next page. Um, if you have n over n plus 1. We already did this before, I think. Yeah, right? This is bounded, right? Bounded. Bounded to value 1, right? We draw, uh, it will be having a line here. This is a value of 1. Okay, and we already proved with limit, right? Remember? This is just a review. So the conclusion will be it will be uh, less than 1, right? For all n. So this will be converged. And also if you have, for example, an alternating series, it will be alternated between sometimes here, sometimes here, 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 here. Or maybe it's in the between here because it's negative, right? But here, like I said before, it's diverge. Okay? Diverge. Okay. So let me write one more time. Not every bounded sequence is convergence. And not every monotonic sequence is converges. Okay. Okay. Let me give you another example. Does the sequence an equal 3 to the power of n? Does this converges? So if you were given this problem, one of few method or observations that maybe it's good for you is just try the few terms. Try the few terms just to see what this looks like before we go into any method. Okay, first just see the first few terms. Like for example, let's start from n equal 1. It's 3 over 1, right? It's 3. And then try to increase the n and make 2. So it will be 9. And then divide by 2, right? Or 4 half. And then try n equal 3. Okay, it will be 27 divided by 3 to 6, right? So it will be same, 9 over 2, right? And try to increase one more time. This is 81 divided by 4, 3, 2, right? So it will be at least 27 over 8, which means it's less than 4.5, right? And if you keep trying to increasing the n, eventually the number will be getting smaller. Okay? So starting from here, the number will be smaller and smaller. So getting smaller. An getting smaller, or an value getting smaller. And from here is actually we can say that if you try to keep n bigger, eventually we'll say that okay, it's monotonic and bounded, and it will be converged. If you keep trying to increasing n, is and keeping larger. Let me write here. Like for example, if you try a 20, you don't need to count. I already count this. 1.43. So it will be 0.0000 something. Okay. So it's actually approaching 0. It's actually approaching 0. Okay. Now from here, actually, from the first few terms, like from 1 to 4. Okay. Let me see from from the first few terms. Okay. Of course, you don't want to count A20, right? It's too much, right? So we can do some observations based on what the few terms looks like. So from the first few terms, n increasing, but an is getting smaller, right? It's getting smaller. So we can conclude that this is an is greater than an plus 1. Okay, we can conclude this case. Okay. And what we need to do is we need just to solve this and using the original formula for the problems. Okay. The function or the sequence is 3n. So we need to divide this and change n with n plus 1. So n plus 1 factorial. It needs to be equal or greater than 1. Okay. And we need to solve this and find which n. This more the solution is more mathematical. Okay. But of course, you need to see at least a few terms and what it looks like. Is it increasing, decreasing? Okay. Now we can solve this. So this will be canceling and 3. And this will be canceled here. Okay. So it will be left with n plus 1 over 3. And we can simplify and find that, okay, n should be equal or greater to, in which we already see from what we have done. Okay. So it will be decreasing from n. Okay. So if you have other problems, then if you want to look whether the sequence increasing or decreasing, you can see first few terms, and then you can prove that by using the definitions of increasing or decreasing. Okay. Okay, I will continue until maybe around 9. Okay, around 9, and we will change the topics to chapter 10. Okay. Now we can move to 11.2. It's called the series. But let me remind you that the sequence, it is this the set of order. Okay, set of order or number. Okay, but series, it's the sum of the order. Okay, which means series is the sum of the sequence. It can be like that. Like for example, half or it can be like this. Or if you see the pi number as in 3141592 blah blah blah. we can separate this become maybe 2. And if you try to add all this, it will become our pi. And if we change some number in the list, then the definition of pi will be also changed, right? So it keeps that way randomly, right? Not really in pattern. And if we add uh, the terms of an infinite sequence, we will get A1 plus A2 plus A3 plus dot, 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 plus AN. And we call these terms infinite series. Or maybe if you want to write completely, we can write this. Because all the series or sequence, we denote the n is until infinity. So actually, you don't need to really write completely because we know that it will turns out to become larger and larger and larger. And there is also we called a partial sum, or we call in terms of S. Okay. So let me write. So given series AN, like we did previously, and let the Sn denote its partial sum. So Sn is let me start with different n. Let's start with I. So AI will be A1 plus A2 plus A3 plus, okay. So from here is actually, let's say from A1 plus A2 plus A3 plus A4, let me have several terms, okay. The partial sums mean this is S1, this is S2, this is S3, and so on, okay. So A1 is S1, A1 plus A2 is S2, A1 plus A2 plus A3 will be S3. Okay, what the partial sum means, okay? And by definitions, actually, if the sequence of the partial sum Sn, so S1, S2, S3, and so forth, if the sequence is converged or is convergent, and its limit of the partial, maybe not using this sequence. Let me just write this. Okay. Is equal as the value of s, okay. Meaning it exists as a real number, then the series is converges. So A1 plus A2 plus A3 plus AN is equal as, or we can say that the sum of AN is equal S. And S is sum of the series if the sequence already diverge, then series is divergent. Okay. So maybe some example. Suppose some of the first n terms of series is okay. Let's just use the example 2n 3n plus 5. Then sum of the series we can use the limit to look up the S. And using this, and of course from the limit we can let me just try answering this 2 over 3. So the approach will be the same, similar with what we did before. We can approach with limit. Okay. That's the example. Let me give you another example and how to deal with this example. The example is find the sum uh, okay, to see um, what the formula means, okay, we can again observe the first few terms. Okay, and let me write the first few terms as Sn. Okay. And let me change a little bit, become I equal 1. So let me change to I to see the first few terms. Well, let's check from 1. Okay, so 1 will be 1, 2. Okay, and then plus or maybe 2, 3. Okay, plus 3, 4 plus dot 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 plus until n. Let's say it's become, or let me write here, n equal. Okay. Okay. Interestingly, we see this few first term is having recursive number, right? At least you will see 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Okay. One idea or one example to solve this is we call the solution is the telescoping sum. The telescoping sum means it's like a telescope, zoom in, zoom out, right? So if you see any sequence or any sum of the series, sometimes you will see like a big chunk of plus, 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 right? The telescoping sum idea is to shrink that plus, plus, plus into how to say that. So we need to find any way to canceling all the middle order. Okay, that's the telescoping sum. So if we look at the S, okay, oh, let me change the color. S is, let me write one more. We can change the form first. Okay, I think we can change this form. Okay, uh, uh, partial fraction. Okay. Now after we change the form, let's try to see the terms. Okay, so S will be from 1 and then 2, right? This is for n equal 1 and then plus. Okay, 1 over 2 minus 1 over 3. Okay, and then maybe I need to move to the left a little bit, and then plus 1 over 3 minus 1 over 4, and plus 1 over 4 until you reach the end, and we say the end will be plus 1 over n okay, 1 over n minus 1 over n plus 1. Okay, now the idea for telescoping sum is you see the number here, half and 1/3, 1/4, and it's actually, you will see all the numbers here, and if you plus them, you will cancel this, right? This method is called telescoping sum. So the idea is you need to see or to find a way to break down this long chain. And then we can cancel. And we say that the S is actually 1 minus, okay? So from here, we can actually approach with limit. Okay. Of course, 1 over n plus 1 will be 0 in limit. So the S will be 1. Therefore, the series converges. And if you look at uh, the graphs, AN will be converged to below and SN will be converged to above them. But I think it's not proportional, but I hope you get the idea. Okay, so the sequence and the series, both can be converged, but they converge to different values. Okay. But I think it also depends on how the problem really is. Okay, what the problem is. Okay, but I hope you can separate between AN and the SN. Okay. So series will be it automatically say that you need to add the terms, but sequence is just a set of number. There is no addition. Okay. Okay, we can move to review for chapter 10. Any questions before from telescoping sum? Okay. Okay, review. Um, I think I believe the parametric sections, the 10.1 and 10.2, is not too complicated. I believe the complicated one is 10.3 and 4. Is that, do you agree with that? Okay, let me start with 10.3 and 4 first, okay? So polar curve. So we are discussing polar curves, okay? So when we deal with the polar curves, the first thing we need to consider is we need to move from, we say, the rectangular coordinate to our theta, okay? Let me give you an example. Let's say from what we did before, we explained that, okay, this is r cosine theta, okay? And to help you understand why this picture matters, okay? Can you draw by yourself and prove that this is true? Because if you are not careful and you mix with the rectangular coordinates, you will make two circles. You will make this mistake. Okay. For example, if any way means okay, please draw r cosine theta. The true answer is just this green one. But if you make mistake and you think in XY coordinate, you will draw these two circles. Because you will argue, okay, cosine have negative signs, right? Sine also. So if you draw maybe another one, sine is here, right? If you make mistake and okay, think like, okay, there is a negative sign of the graph. So we will also make two circles. What I do mean is, if you have, let's say this is the baseline, polar axis, okay. If you increase a few degree, let's say the angle theta here, of course, if you're just looking at this, you will see, okay, this is r theta. Like in the circle, the r will be always constant, right? So when you rotate the theta, the r will be always positive, right? But what will happen if r negative? Maybe sine, if you have, for example, sine 5 plus, it should be negative, right? Or maybe 6. So I will write this. How to make it a graph. If you're not careful and you are thinking that, okay, if we have positive, negative, you will make this mistake, the red circle. Now the point is how we draw the negative one. Yeah, yeah. We need to mirror, okay? So the negative one will be here. So every time we are moving, let's start from here, okay? Let me erase this part. Let me make bigger. We start from 0 here. Cos 0 is 1. So we agree, okay, we can start from here. And then we are increasing, still positive because all the first quadrant is positive, right? Until we got pi over 2 here. It's 0. And then increase pi over 2. What will be? Pi over maybe let me write cos maybe pi minus what? Pi over 3. This should be half. Yeah, I want to move to here. Okay. So it should be negative half, right? So what we are doing is we go from pi over 2 to pi, right? So we are moving maybe around here. This half, the negative, if we find maybe around here, should be here, it should be mirrored to here. That's the key. Okay, that's the key. We are not drawing the negative, but we mirror them to the opposite sides. That's the rule in polar trips. That's how you draw the circle. Okay, got it? Okay, so every time you have the negative, you find, oh, it should be here. Then you should mirror them to the other side. So the negative is actually the other side of the positive one. But you cannot draw the negative one. That's the polar. Because in all polar, the R should be always positive. Okay, so the negative one is actually the other side of that what you draw. Okay, okay. I hope you understand. Okay, I hope you understand. You can try to draw, but I think you can draw this at home. And I will attach in the Moodle, I will attach some YouTube videos to help you observe what is happening in the polar. Okay, like the cos 2 theta, why it's like the curve like a rose. Okay. And it's actually true if you are thinking that, oh, the negative will be the opposite side of the positive. If you keep doing this, you will get eventually this this curve. Okay. The way you draw this rose curve is not, oh, it's 0 and then pi/2 and then go here, go here, go here. No, 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 no. You will find interestingly the curve will go here, will go here, will go here. If you are considering the negative, okay, and you can try if you want, and I will show you how in the Moodle, okay, because it's long. Okay, there's the some important point for the polar curve. I hope you get the big picture on how you're doing it. And then okay, let me give you. Let's start with some exercises and uh, exercise. Mm, let's start from find the area of the region that lies inside both curves. Number A, I just start from, maybe it's the simple one. 3 sine theta and R3 cosine theta. And then the other one is sine 2 theta and R cos 2 theta. Okay, maybe that exercises first. I think I can give you a few minutes to solve. Let's try maybe 5 minutes first. Okay. Any solution or anyone solve? What happened? Yeah. You can do that because it's symmetry, right? Yeah. But the other one? So you need to make sure that the picture is identical, right? That's the key. So you can just multiply. Yeah. Yeah. So number B is sine 2 theta and cos 2 theta. It's actually the same identical rose curve, but different position. Okay? So actually you can use the symmetrical approach. Okay? In any way, most of the polar curves, you can simplify the formula by using symmetrical approach, because that way the calculation is much more simplified. So it's really really good if you are having a good visual, good picture. Okay, if you cannot picture off all of these curves, then you cannot go further. Okay, that's I think the most difficult part. How to visualize the curve and imagine how the curve will be shaded by the what we need to find the area, right? And the key is you need to think in a polar coordinates, not in a rectangular. Okay. Ya, simetri kan? Atau udah selesai belum? Mhm, 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 mhm. Satu lagi dong. Enggak, sama kayak cos 2 theta, cuman diputar. Persis sama, identik, identik gambarnya. Yeah, you need to just, if you, mhm, mhm. Yeah, you find the intersection first, right? And then what? Mm, so if you can split this, right? So it means uh, if you can find from here until here, just this circle and multiply by 2. Does that make sense? So if you have this, right? This is from this intersection, from theta here, right? Until this is theta equal what? Pi over 2, right? So this is the cos, right? Yeah. So this is 3 cos theta, right? So you find the half, okay? But you are finding it has 2, right? So you find this area and then you multiply by 2 to multiply with this. Yeah. This is theta equal this, right? And you, mm-hmm. Yeah. Just from here until here, and then multiply by 2. Okay. Oh, what's your answer? Let me give you some. Well, what the idea means. Okay. So if you check here, you get some theta intersections, right? Okay. If you let me use a different color here. Let me use some lines here. Okay. So if I draw here, this is from some theta here, right? Until theta what theta pi over 2, right? So if you can find this, right? From only 3 cos theta multiplied by 2. You get it? Okay. Yeah, you need to draw. What's your curve? Yeah, 3 sine. You need to draw like this one. This is cos theta, right? The sine will be here, right? Yeah, you need to draw that first, and then find the intersection. Hmm? Ini apa? Digambar dulu. Hmm. Mau nggak mau harus digambar dulu. Kalau nggak susah ngebayangin. Pusing ya? You got it? Hmm? How you solve it? Yes, first pi over 4, right? Mm-hmm. Yeah. Let me check. Okay, let me draw first. Okay, what is the graph looks like? So first, this is 3 cos theta. Let's say this is 3 cos theta, and the other one is up here. It should be the same size. Okay. And again, we need to solve this, or we need to think in a polar mindset. Okay. So the question is asking the area inside both curves. So the inside will be this curve. Okay. And let me make a separations here. Okay. You will see that because the two circle have the same size, the diameter is the same. So this area inside will be symmetrical. Okay. If you can find the theta here, the intersection, okay, just by looking at the 3 cosine theta, you can see the area here is just from this theta until pi over 2. You can find that area, right? You can multiply by 2. Okay, I think that way much more easier. Unless if you want to combine from this and then plus from this, that's also fine. But I think you just think like with similar approach. Okay, if you can prove the symmetry, if it is identical, my suggestion is just use symmetry. In your calculation, much more simpler. Yes. It's the same size, right? Yeah. So you can you can use the, for example, 2, you can use for sine, for example, half, and then 3 sine theta d theta, or you can use also from pi over 4, pi over 2, half, 3 cos theta, and then square. And then you can solve it, use the double angle formula. I believe the answer should be, the area should be 9 pi over 8 minus 9 over 4. Okay. And for number 31, or number B here, if you check your book, maybe it's number 31, but I'm not sure. Okay, to check how the intersections looks like, it actually you can see from the sine 2 theta, and then you need to equal this both, and you can say you can get the tangent should be 1. So you get the theta is or 2 theta is pi over 4, so theta will be pi over 8. So around pi over 8, it will have the intersections. Okay, so the way the curve should be is from here and from here. Yeah, around like that. But keep in mind that this is identical. Okay. And now, again, this is all identical. So this area, all this area will be the same. So we can say that we have 8 area. So we can say the area will be 8 multiplied with 2. So let me explain. This area has 8, and one area each of them will be. Let me make bigger, like that, right? This is the area. So inside this, the red color, we can see that it's actually, we can divide by 2, and it's symmetrical. Okay, so that's why I will write down this as 8 area multiplied by 2, these 2. Okay, so 8 multiplied by 2, and then integrations from 0 to pi over 8, the intersection. And let's say we start from sine squared to theta. Okay, I always start from try to find the 0, 1 because I believe it's much more easier to calculate. But that depends. You can also using the cos and using different value that's still fine. But you will calculate it at different value, right? But the answer will be the same. It will be the same. And this will be resulting pi over 2 minus 1. Okay, so for the exam, I will emphasize more on how you get the formula. Okay? And if the case or if the problem has several possibility, then you can write one of them. Okay, I will just make the other one also the same points. Okay, if you because this you can use the cost, right? It depends on you, which one you are preferring to calculate. Okay, okay, maybe to help you see the curves. Okay, let's say this is the pi over 8. Okay, okay. So if you are using the sign, so you are from 0 and you're going up, and actually you are finding the half, this half. Okay, and you multiply by 2, you get the full leaf, right? And you multiply by 8 because it has 8. 1, 2, 3, 4. Okay. If you are using cosine, you can also do that. So you can from pi over 8, you will move here and up until pi over 2, 4. Yeah. 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 Okay. Let me give you, I think, another exercise. Um, okay, let's say the question is find the exact length of curve. Let's say A, R, let's say 5 with power of theta, and 0. I think for the arc length, it's much more direct. So you just need to remember what the arc length is and just input the number. Let me give you the other one. Let's say B is R, sine Okay, this a little bit review for your calculus one, how to derive the, you have some constant and then power of some variables. Yeah, the answer is, I think a little bit complex, but um, how to solve it is actually not too difficult. Okay, the question is, do you remember how to integrate? Yeah, because I think you need some method. Okay, how about number 1? Any idea? Number A? The integration of this is it, right? The integrations. Yeah. It's correct. Yeah, I think it's correct. It's similar to my answer. Yeah. Is it too much for you? Or really? Can you solve this? Yeah, it's already correct here. Yeah, so you need to see that this is having the same fact. You can factorize this, right? And you will have a constant. And the constant you can move up. Yeah, the constant, not the further. Yeah. Salah rumusnya. Dulu pakai yang polar. Ini. Tinggal masuk dari sini. Itu dari iya. Integral bayangin aja dibalikin. Gimana coba dapet ini? Tapi di sini udah. Udah oke. Lebih cepat gitu sih daripada ngapalin metode. Oh, why having two theta? But it's square root, right? Yeah, I think correct. Your answer correct. Yeah, it is correct. But I think it's not. It's 5 theta over this. I think you can check derive. You can derive. Check to derive. But it's similar. Yeah, the answer is okay. Oh, udah. Ini konstan kan? Konstan keluarin aja. Tinggal integral ini. Ingat nggak integralnya? Nggak usah ingat sih. Dicoba-coba. Dicoba-coba gimana caranya supaya dapat kalau diturunin jadi ini. Kan kamu udah dapet nih. Ini gimana sih? Ini turunannya kan bisa diturunin kan? Ini kan turunannya kan? Bisa kan diputar-putar kan? Okay. Yeah. You can continue. You see, 5, 2, 5, 2. Same. Can you factorize? Okay. You have factorized 5, 2. Go to outside, become 5 and theta. And you still have the square root, right? The square root is constant. You can move the constant outside of integration. So the integration is only 5 theta. Okay. Yeah. Continue. 5 squared theta. Yes. Yeah. Wait. Up to here is correct, but why here? I think you have mistake the square root. If you remove the 5 squared here, then the inside should be 1 plus.
Oh, yeah.
Right? Okay, but it's correct. It's correct. You have a problem? Okay. Mhm. Do you have do you have any problem in parametric?
More or less, but I'm doing the review from chapter 1.1,
Mhm.
and now it's chapter 10.2.
Mm.
Yeah.
Do you know that the international office they offering the you can get a tutor?
Yes,
Okay.
yes.
Have you applied that? Yeah.
No, but today I want to go.
Okay, okay, you can check there because I believe most of the problem is the calculus one problem. So
Yes.
if you still have problem with that, you need to catch up with the calculus one.
Yes, but the chapter 10.1, I understand.
Okay, okay,
I
okay,
already have a review.
okay. Okay, I think most of you get the good results for the at least the big picture on how you get the formula. Okay, so the formula will be the let's say theta 1, theta 2, and you get the r squared and then dr d theta squared and then d theta. Okay, this is the basis for the formula. So for number 1 or number A, you get the r is 5 theta, and dr over d theta. Remember the 5 over with the power of x in our calculus 1. We will get the same 5 with the power of theta and then multiply with the ln 5. Okay. Remember that if you have e, okay, let's say e to the theta, this is actually e to the theta and ln e, right? Which means ln e is 1. So that's why you have the same e to the theta. That is the thing that happened. Okay. So when you're changing this e, if you change to number, then it will be ln 5. And that this is the first reference. Okay, I hope you still remember how to derive. Okay? And the next thing, we can input from 0 to 2 pi. Let me just write the 5 theta, 5 with the power of theta, sorry, squared plus and then squared and then d theta. Okay. From here, we can see that 5 theta squared or 5 with power of 2 theta. This is also 5 with the power of 2 theta. I can factorize that out. So one plus, okay. And now, because this is a constant, so I also can move that outside of our integrations. And then integrations 0 to 2 pi of 5 theta d theta. Okay. Now, because we already have this dr over d theta, okay, let's find how to integrate 5 with the power of theta. You can try some trial error. I don't think that would be difficult. So you write the constant, and then this will be 5 over theta divided by ln 5. Okay, from 0 to 5. Because if you derive 5 with the power of theta, you will get 5 over with the power of theta and then ln 5. To get what we need to cancel this, right? Okay. So that's why I need to divide by ln 5. Okay. You can solve this, and eventually you will get 1 plus ln 5 squared divided by ln 5, and then 5 to pi minus 1. But this exact answer, unless you are offered with some options, I don't really need this answer. If you just answer until this, full point. Okay. Okay. So the quiz will be also applied. Okay, if you just up until here, but you need to, of course, you need to solve the integrations. Okay, but no need to input the value. Okay. Okay, the other number is number B. R is sine cube, right? I think we can try to find the RD theta first. So what will be sine squared, right? And then multiply with cos this, right? And then, okay, I think I can just apply the formula. This seems long, but actually not really that hard. So this will be sine 6, okay, plus sine 4, and then cos squared. From 0 to pi, right? Okay. We can factorize, right? And eventually you will get, after you factorize, you will get sine squared. Okay. So you will get from the sine 4, okay, this one and this one, okay, and you get the square root, and you will get this, okay. And every time you get sine squared or cos squared, just use the double angle formula, okay, to solve that integration. You will get eventually, let me write the solution for integrations. 3 over 2 sine 2 over 3 theta from 0 to pi. Okay. And this, if you want to calculate, it's not too bad, right? Not too bad. Not really in the long and large answer, but yeah. Yeah, you need factorize. Okay, factorize. Okay, any questions? Okay, so I think that's it for the review. I will also upload this note and the link for some YouTube videos to help you catch up with the polar curves. And have I sent you the how to graph polar curve already, right? The Desmos link in the Moodle. I think I have already uploaded that. Okay, you can try to use that also to find uh, any polar and how to remember the pattern, at least the pattern. Okay? The rest will be easily to follow. Okay, okay, I think I will end till here. Um, if you have any questions, you can come to me or just email me.